So let's talk about how to design password protection system by using keypad LCD combination by using Keil and Proteus combination. So just go through your Keil microvision tool, which is for to develop embedded C program, and Proteus simulation tool, which will help us to check the hardware result. Just double click on Keil microvision. So this is the previous project which is going to open. So from this, just select project tab and select the option new project, and from here just go through your where you want to save your project, which is our password protection system. By using keypad and Proteus combination, give your project name and click on save. And this is the window for choosing the microcontroller from different manufacturers, and from here just I am going to choose the manufacturer name as Atmel and click on this plus mark. It will show the list of devices, and from this series just choose the device which is AT89C51 and choose the specific microcontroller from specific manufacturer and click on OK. And this is the startup code warning and click on no. Now you people created your project with a specific target device which is Atmel AT89C51 controller. Now this is the time to open editor window. So go file tab and select the option new. This is the text editor. Here our people have to write program. Before writing program, just I am going to save this text file. For that, go file tab and choose the option save and give your program name here, which is password protection system. With .c extension. This is my program name. You have to save always program name with .c extension. Now, so go for your declarations, and the first line from our embedded C program, which is the header file of 51 families, which is reg51.h. And next, so go for the hardware declarations, what you are expecting for your complete password protection system design. So I need one keypad, so go through your hardware declarations, which is I am working with 4x3 keypad, so 4 rows 3 columns. So make sure your rows and columns connections with a specific IO lines. This is row 1 declaration and row 2, which is connected with P1.1, and row 3, which is connected with P1.2, and row 4, which is connected with P1.3. And now I will go through the columns connections. Column 1, which is connected with P1.4, and column 2, which is connected with P1.5 IO pin, and column 3, which is connected with P1.6. these are my hardware declarations. I'm doing with 4x3 keypad. Next, I make sure your display connections with your device, which is S bit or S, which is connected with P3.0, and RW, which is connected with P3.1, and enable, which is connected with P3.2, and the complete data lines which are connected with port 2. Now, so these are LCD control lines. Next, so just I want to open electronic door with the help of motors connection. So just make sure your motor connections with the other IO pins what are left from port 3, S bit, motor N. So these are the two poles. Just I am representing with motor, a single motor I am taking to control my door with the help of DC motor. I can show you now. So these are the motor connections. Next, so I am declaring some user defined functions. So one function for command, and other function for which is unsigned char argument, and one more function which is with dat, which is also with character argument, and the other function which is used for passing the strings to the LCD screen. So one for pointer variable and other for size. Next, I am taking one more user defined function with null value return, which is delay without arguments, and to check the password, so just I am using a function check, and to store the password, so just I am declaring a password size of 10. This should be my mobile number. So I can make sure my password with 10 character size. And from here my main program starts. So initially just I am declaring my LCD with the specific commands. With LCD CMD 0x01, this is for clear screen, and this is the command for display on, cursor blinking, and other command which is for shift the cursor position to right, and the next command which is started from 0x80. So these are the basic commands need, and this time using this LCD display function with my password protection system, and count your number of characters: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you people can take even 20 by 4 size LCD screen rather than 16x2. So how many characters here? 4, 5, 6, 7, 8, 9, 10, 11. Space also consider as one character: 12, 13, 14, 15, 16, 17, 18, 19. And give the size. And if you are looking to go for second line, with the 20x4, you should pass the command LCD command 0x94. So to pass the second line, this is 0xC0. And make sure the other text what you required from LCD screen: system, and number of characters 7. So this is my initial text I required on LCD screen. So now I am entering into the loop. Infinite loop, which is while of 1. Now the process will continuously monitors on this infinite loop while of 1. Now, so just make sure your LCD screen clear. For that, LCD command 0x01, which is going to clear the complete screen, and give the text enter password. And just 4, 8, 9, 10, 11, 12, 13, 14. So give your size as 14. And this passwords I am going to allow in the second line. For that, 0xC0 is the command. This is the cursor position. Now, so to scan this keypad, this I am writing R1 equals to 0, and I am checking all column status. And what we are expecting if column 1 equals to 0, so password of x which equals to and save the data. with password fx as 00 and give some time delay to read the character from this column, and increment your x value by 1. So to store the next character or next key from your keypad scanning, if c2 equals to 0, and what character you are expecting, and if you want to display the same number as so LCD dat of star. And next, so if you want to read the next character from this, and just I am saving this key of x, which is as 2, and the same display as star, and increment x value by 1. This is the second key scanning, and if you are looking to scan the third key from row 1, if c3 equals to 0, so in the password I am going to store as 3 and as followed by delay, and give the display as star. So this is the star I am displaying for password hiding. Rather than number, I am displaying star on screen, and increment your x value by 1. This is the complete row 1 scanning. Next, so if you are scanning row 2 by making R2 as 0 and R1 as 1, this is row 2 scanning. For this, again your pupil follows column 1 and PWD of x, which is 4, and delay, and LCD dat as star. And increment x value by 1. This is a common logic for all remaining keys, but based on row and column scanning, the number will be changed on PWD. If C2 equals to 0 here, so PW of x, which is 5, and delay of, and LCD dat of star. And x equals to x plus 1. If C3 equals to 0, password of 6, password equals to 6, and delay and display as star. And increment x value by 1. So just make sure you are all columns by row 2 scanning. Next, so next R3 is 0 and R2 becomes 1 now. So here our people will scan again C1. So once C1 is 0, then password of 6, password of X, which mentions that, which is going to key the 7 key. Delay and LCD dot as star. So I don't want to disclose what key I am pressing as a password. And X equals to X plus 1. This is row 3 and column 2. Next, and C3 as 0, sorry, C2 and password of X, it should be 8, and delay and LCD dot as star, and X equals to X plus 1. Next, if C3 equals to 0, which means password of X, which is 9, and delay LCD data of star. And X equals to X plus 1. And this is about R4 scanning. If C1 equals to 0, PW of X is star, and delay and LCD data also as a star, equals to x plus 1. Next, if c2 equals to 0, pw of x, which is 0, delay, and LCD that as start. And x equals to x plus 1. Next, if c3 equals to 0, this I am going to use as an enter key for my password, and here I am going to call the function check. This is for password check. Use some functions here as delay much more. After this, R4 as 1. So just I am verifying the braces. Next, so just I am giving the description of all functions. So this is check. Here just I am checking pw of d, pw of 0, equals to 9. This is my mobile number, and I am verifying with all order pw of 1, which is 6, and pw of 2, which is 7, and pw of 3, which is 6, and pw of 4, which is 3, and pw of 5, which is 2, and pw of 6, which is 7, and pw of 8, pw of 0, 1, 2, 3, 4, 5, and 6. This is 7, which is 1, and pw of 8, which is 1, and pw of 9, which is 8. This is my total condition. If this condition matches, then just I am rotating motors and change the display as so. Just clear the screen and LCD display. Password successful. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Delay, and whereas else part is something LCD display. Password. This is 5, 6, 7, 8, 9, 10, 11, 12, 13. So give your size here. This is my check function. And what about other functions description here? Void LCD command with unsigned char value, and give your assignment, so p2 as value while passing command. So make sure your control lines as 0, RS as 0, RW as 0, and enable high to low. And next write down your LCD dat function, which is unsigned char dat, and whatever the argument you are passing, just equate with data lines. But while passing data, RS logic should be 1, RW logic as 0, and enable high to low. This is the data function, and give the description for display function. And take one temporary variable to repeat the loop until 0. So execute data function based on the count size. So just you have to pass these characters also one by one with the help of that function. So that you have to write with the help of SFW. And now write down the description for delay function. Which is with two integers. So I need integer I comma j. Take the help of for loop. For I equals to 0, I less than so 4000 I plus plus, and for j is equal to 0, say less than 100 j plus plus. This is the delay function, and declare a temporary variable x here. So this is all about my functions. This is the complete program with respect to motors. Now if you want to see the output of this program, just add, which is password protection system, add this file, close. And to see the errors and warnings for this program, go project tab and click on the option. So just give one equal here. And this is as just write down your AND symbols here to differentiate the condition. And if you want to see this program output with hardware simulation, try to create hex file. So by selecting the options for target 1, and highlight this use on chip ROM, and output create hex file, and click on OK. Now this is your complete embedded C executable file, which is created as X file. And minimize this and open hardware design. Now so choose the components required for this. One is controller, and other one keypad, this tool is not responding, just wait. Now we got the device into the list, and give the keypad. Take your keypad, which is 4x3 phone keypad, and next I am taking LCD with 20x2 size. and next DC motor. So just connect all individual components in the design. So what you required for this, and based on your hardware declarations, just make sure your connections. So all rows which are connected with port 1, and columns are connected with P1.4, P1.5 and P1.6. and now, so coming to these control lines which are connected with port 3, and data lines which are completely connected with port 2. And to observe the motor condition which are connected with P3.3 and 3.4. This is the complete hardware design, and browse the hex file by choosing this program file option, and which are present in embedded C programs. So password protection system, and give the same clock frequency as 11.0592. Now you can play it. And now you give your character. Okay, just I will give this message on so before while function, and if you do any modification with your program, save and build it. Now you can see the response. Okay, something is wrong. R1 is 0. So you should make R1 as 1. Just verify where this P1 remains 0 always. P1.0 pin remains. You don't have any other connections with P1, right? Now, so check this program, which is just I am giving my mobile number, so which is allowing so many times, so and increase the delay for each and individual key, the delay program, more time. So this is applicable for each key in this. So come from first condition, because of this delay become very less. So which is allowing one character as 4 at a time. So otherwise you people can write other delay value by taking more values in the delay program as separated as keypad delay. So this you can take. Go for design by increasing your delay value. Just I am giving random words, random keys as a 10 size. I'm pressing hash. So this should be your password wrong, and make sure your all columns and rows which are working. even for this also just try to increase the delay values. And save and build. Now you can test your output by giving right password. Now I'm giving 9 6, so 6 is taken 2 times, so again you have to run your program. So it's 9 6, so 6 is taking more, 6 required more delays. There is 6, so which is taking 2 times, so I will allow one more delay. So if delay is not suitable for you, then go with other delay values. So now 9 6 7, again wrong because my password is 9, so again 2 times, 9 6 7. And 6 7 6 3 is taken 2 times, so my password is 9. So once you people make it delay more, then there is no problem here. 9 6 7, so make sure more delay in the program. There is no complexity here. Allowing more delays is most easy for us. This is for all characters. and build. Now you can verify your output by playing your simulation. Nine, 6, 7, 6, 3, 2, 7, 1, 1, 8. So once password match, your motor starts rotation. This is the way you people can test. If suppose you're going to give wrong password, like 8, 5, 6, 3, 2, 1, 7, 8, 0, and I'm going to press. This is the way you can test, and there is no rotation from your motor. Thanks for watching.